Our first lab involved the constant velocity of an object. For my lab, I chose a billiard ball. That was the video I shot of the billiard ball. After shooting the video, I uploaded to Tracker and then tracked the position of the ball frame by frame to convert the data from the video into data we could physically see, as you can see on the right side of the Tracker screen. Using this, I used the table and also the chart to compare it to a computational model that you will see in a minute. Here you can see my video analysis of the data I obtained from Tracker. Using this data, I calculated the observation start time and also used the first two values for the x position to determine the initial velocity. This initial velocity was what I eventually plugged in to the VPython program to calculate the continual velocities and positions for the model that we later created. Here you can see the code for Python that I modified using the parameters identified for my billiard ball. When running this code, it creates a model of the ball on the left and a graph as seen on the right of the position. Here I compare the data outputted from the Python CSV file as indicated in my code to the data produced by Tracker. Trackers is the experimental position, and the position graph, position data points are those that were produced from the model. The red points and the trend line indicate the model, and the blue points indicate that from Tracker. The reason there is a deviation is because of the error created when the pool ball was rolling, presumably from the friction from the ground or due to other external factors such as my initial push. Though these points don't match up, we can see that initially they do, and that as the ball tapers off and slows down, the data points sort of curve away from the model, and that's why there's error. However, for the most part, the points link up, and we see that though there isn't constant velocity, we can see where it would be.